Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Greetings. My name is Muhammad Aufa Arib and my friend Virgi Febrian Hermawan from Group 6. Here we'll be presenting our ISAS assignment entitled Automation Sanitizing System using Arduino with ultrasonic sensor. Let's get to it. First, we're gonna talk about what is IoT. IoT, or Internet of Things, is a concept where an object has the ability to transfer data over a network without requiring human-to-human or human-to-computer interaction. And second, we're gonna talk about pandemic situation, that is SARS-CoV-2 or COVID-19. COVID-19 or corona virus or severe acute respiratory syndrome, coronavirus 2, is a virus that attacks the respiratory system. Therefore, the government made 3M due to the increasing number of COVID-19 spreads. There are many areas that carry out strict prevention, and many people are also increasing the implementation of IoT's technology or smart connected ecosystem. And this is the smart connected ecosystem. IoT consists of a large number of devices, including intelligent sensors, actuators, and data-driven devices, and applications that can enable intelligently connected communities. And if we take full advantage of various IoT devices, it will strengthen the health and economic posture in fighting the COVID-19 situation. For example, automatic sanitizing, which can be used in the health sector and even in all fields to prevent physical contact and make it easier to wash hands. And this is the next topic about automation sanitizing that will be explained with my friend Virgi. Please.
Okay, thank you, Aufa, for the explanation about previous slide. Please, next to the next slide.
Okay.
Okay, in this slide, I will explain about flowchart automation sanitizing. Flowchart is a description or a detailed depiction of the program flow by using symbol as a depiction of methods by connecting other methods. This starts the stage of a research. A system design is need and determine the component needed to design a hardware prototype and can be seen from the flowchart figure beside. The system will first start or turn on the entire system. Then the ultrasonic sensor system will read whether there is a hand within a predetermined distance or not. Then it will pass to Arduino to make a decision on whether the sanitizer will work or not. Depends on finding the hands in the sensor. If there is no hand, the system will return to the process in ultrasonic sensor. If not, then it will continue to the servo motor to press the sanitizer so that the sanitizer gel will come out to use and the system is complete and return to the starting process and continues. And this is name is looping process. Please next. And this is the hardware design. The input from the Arduino Uno microcontroller is the ultrasonic sensor, while the output is a servo motor. The ultrasonic sensor process detects an approaching hand. And just as explained in the previous flowchart, the system will make a servo motor move and issue an antiseptic hand sanitizer. The function of the servo motor is for driving, while the servo motor serves to push the cleaning fluid out. Please next. And in this slide is software design, which is related to programming related to how this automatic sanitizer is able to run according to the plan when the system is working and running. And can be seen in the picture beside. This is an example of the code in the Arduino IDE to drive the servo. Next, for the equipment and material, for the equipment needs with the material is used to design automatic sanitizers can be seen as shown in the table. For the tool, we use first Arduino Uno R3, ultrasonic sensor, servo motor, jumper cable, and breadboard. And the function of Arduino Uno is for roll for controller. And for the use ultrasonic is roll for object controller. For the servo motor is play a role in driving the sanitizer, and the jumper cable is served as liaison media, and breadboard is served for coupler. And total we use in the automatic sanitizer is for the Arduino is 1, ultrasonic sensor is 2, servo motor is 3, jumper cable is 40, and breadboard is 2. And please next. For the mechanical design, which include the form of a series of mechanical design on automatic sanitizer, by designing a series of tools that some of the components require hardware device that match the placement of the sanitizer. And this is the picture of the design the automatic sanitizer. Please next. And this is the implementation and result about the automatic sanitation. And this is the end of the design, and the result of testing of the automatic sanitizer can be seen from a distance of 0 to 11 centimeter. The servo saw a moving reaction and release the sanitizer gel in a 1-second reaction. But if it has touched the number 13 centimeter and above, the servo reaction and the sanitizer gel will not come out at all. The proof the proof that there are still shortcomings is in the distance that may someday be fixed. But for now, this is at distance of 0 to 11 centimeter. It is already very good to reduce the prevention of propagation. However, it is a very useful to reduce physical contact with the use of hand sanitizer, which are usually prepared in the public environments. Okay, maybe that's it for me about the explanation the system of automated sanitizer. Okay, next.
Okay, thank you for the explanation, Virgi. And now I will explaining our conclusion and suggestion. First, the conclusion of the design and manufacture of automatic cleaners using the Arduino ultrasonic system shown in the table above is it is obtained if the ultrasonic sensor distance is from 0 to 11 centimeter. It can read hand movement and move the servo to remove the cleaner. However, when it reaches a distance of 13 centimeters or a distance that exceeds the Arduino ultrasonic sensor, the system will not move the servo and automatically does not issue the sanitizer. However, this design and system was formed to prevent the spread of transmission of the coronavirus, where it prevents direct physical contact with sanitizer tools, which are usually provided in public places. And this is our suggestion, is to improve the tool again and develop the system, either combined with other microcontrollers or added components to improve features and are useful for the future, especially after the pandemic, so that these tools can continue to be used at any time. Because basically, the current IoT field will continue to grow or develop rapidly, especially in technology and other industries. And that's from us. Thank you for watching this presentation. We are sorry to any misconception information from our presentation. Thank you and wassalamualaikum warahmatullahi wabarakatuh.